Hello and welcome to Biology Interest. Today we're going to be looking at the chi-squared test as a statistical test. So, step 1 of the chi-squared test is write a null hypothesis. This could be, for example, there is no significant difference between the number of woodlice found in dark and light areas of a forest, as an example. Woodlice is a good example here and is often used, although you could use genetic tests as an example as well. But you're not looking for a significant difference there, because you want the number of results of gain from the offspring to be similar to your predicted values in that one. But I'll talk about that later. So after step 1, you've got your null hypothesis. You do step 2. You have to choose the correct statistical test for your data. In this case, as I've already said, we're using a chi-squared test. Now we need to know the reason why we're using a chi-squared test, and that's because we're comparing observed values against expected values. We're using categorical data, that's the main one. So chi-squared in that sense, which is two conditions, in this case two conditions, light or dark. So after that, step 3, you have to use the statistical test to find out if there is a significant distance. In this case, it's chi-squared equals the sum of the observed minus the expected squared over the expected, where O is your observed value, so the number of woodlice you count in each area in the field, and E is expected value if they in equal amounts go to each area with no bias towards one area or another. So here's an example table. Observed values, expected values, the observed minus expected, the observed minus expected squared, and then the observed minus expected squared over the expected, and then added together, you get, for this test, a chi-squared value of 4.58. Now, once we have the chi-squared value, we can move on to step 4 of the statistical test, and that's interpreting the statistical test data, the result from it, the 4.58. Now what we need to do is we need to look up the critical value of the chi-squared in a table of probability to find out if this is significant. What you need to know to be able to look this up is the degrees of freedom, which for chi-squared is the number of categories, in this case 2 minus 1, which means we have degrees of freedom of 1 for this experiment. And in this case, the degrees of freedom for 1 at a probability of 5% level is 3.84. Which is what I'm just going to write down now. Probability 5% is the probability that 5%, less than 5%, that it's caused by chance. So as our calculated value is 4.58, it's bigger than the critical value at 1 degrees of freedom. Now, if the value of chi-squared is greater than the critical value, you reject the null hypothesis, and this means that there is less than 5% probability that the difference in distribution is due to chance. This means that there is a significant difference in the distribution of the animals, and you may be expected to come up with a reason like they like light or they like dark because it tends to be more moist or something like that. So you need to be able to write those points down kind of like that. They look for each of those things. And now you also need to know if the chi-squared value is lower than the critical value at 1 degree of freedom, you actually accept the null hypothesis, which is what would happen if there is no significant distance. And this means that there's a more than 5% probability that the difference in distribution is down to chance. This means no significant difference between the distribution of the animals. And so there's no significant difference, and your statistical test has proved that there's no difference between the light and the dark doesn't affect these animals. Meanwhile, if there was a significant distance, it shows that light or dark is causing a difference because maybe it provides some kind of evolutionary benefit or something like that, which you'll have to think about and evaluate and write down in a question generally. So that's it. Please like and subscribe, stay tuned for more videos. Thank you.